So we are going to do another example here, and this one is to change 400 inch power 3 per day to centimeter power 3 per minute. So again, I would like to draw a very long line here. So we are going to start by writing down that 400 inch power 3 and day. And then the other section, we are going to convert 1 inch to centimeter. 1 inch equals to 2.54 centimeter. However, you can see here this is in power of 3, so what we need to do is need to do some parentheses here, a bracket, and all of these need to be of power of 3. And then we do another section here. 1 day equals to 24 hours, and then another section, 1 hour equals to 60 minutes. So you can see here the way I arrange it. For inch, if you want to cancel out inch, so the other inch should be at the bottom, this is on the top, and for day this is at the bottom, so I will have to put it in the opposite position. This is at the bottom and this is at the top, so that we can cancel it out. So at the end we are going to cancel inch power of 3 here, and then day, hour, and for this don't forget to 2.54 need to be power of 3, so the final answer will be 4.56 centimeter cubic per minute. So this will be the final answer. So I really wish that after this in the assignment or in the test or in the exam, when you solve question like this, you need to do it in a proper way like this, so that we can see which unit have been cancelled out, which unit to be converted, and what is the conversion factor, and so on. So equation must be dimensionally consistent. What does it mean by dimensionally consistent? That means that let's say A is equal to B, the unit here and the unit here need to be dimensionally consistent. Yeah, so I'm going to show you another example here, example 1.3. Your handbook shows that microchip etching roughly follow the relationship D equals to 16.2 times 16.2 exponent negative 0.021 T for T less than 200, where D is the depth of the edge in micrometers. Okay, so this the value, the unit is micrometer, and T is the time of the edge in second, so this is in second. So what are the units associated with the numbers 16.2 and 0.021? Convert the relationship so that D becomes expressed in inch, so D need to be converted into inch, and T can be used in minutes, so this we need to change it to minute. Okay, so what do you mean by dimensional consistent? That means if here D is in micrometer, that means this part also at the end will also have micrometer, so it's going to be the same units. So that's why we assume that this at the end is going to have the same unit. The same unit here will be having the same unit here. So here the issue is here is already in micrometer, and then the question asks to change to inch. So what will happen to all these figures and numbers? And then to add it up, this t is in minute instead of second. So I'm going to show you how to do it. Let's just start properly by list down all the things. Okay, D is in micrometer. We need to change to inch. And T is in second. We need to change to minute. Both values of 16.2 must have the unit of micron. The exponential must be dimensionless. Okay, you can see here we have this exponential here. Okay, the key is this value -0.21 times t must be in dimensionless. That means that if t is in second, this 0.021 need to be in second power of -1, where after that we can cancel. Okay, so exponential, we need to have the value here in dimensionless. So 0.021 times t. Okay, t is in second. So this value should be in second negative of 1, so that we can cancel this, so that the value here after you times 0.021 times t should be dimensionless, so that this exponential can be calculated. Otherwise it's impossible for you to calculate the exponential if you have a unit here. So by considering that, we need to consider that in our calculation here. So I'm going to start by doing D. This is already in inch, and then we are going to draw a long line here, 16.2. okay, so it's D is in micrometer, so this is also in micrometer. The section is to convert it into inch. 1 meter 10 power of 6 micrometer, and 1 meter equals to 39.37 inch. Okay, this is the first section for this one. So this is micrometer, this is should be micrometer. So this is inch, this also need to be converted into inch. What about this section? Okay, so what we are going to do, this is just a continuity from here, because I cannot, because it's too long. So 1 exponential, okay, negative 0.021 per second. As I mentioned before, it's already in unit of second by considering that it should be dimensionless, and we need to convert into minute, second, minute, because the t is already in minute. So we cancel this okay. So at the end, sorry, I really hope that you're going to understand my handwriting, because it's a bit terrible. So at the end, the answer will be 6.38 times 10 power of negative 4 times exponential negative 1.26 t, in which this t is in minute. And all of this is 3, all of this are in, at the end, is in inch, because this is in inch, so this is also in inch. And I know it's a bit confusing at the very beginning, but from time to time you need to understand it and try to repeat it, and also do other exercises in order for you to understand what does it mean by the dimensional consistency. So maybe later, if we have some online classes together, I'm going to explain a little bit more about this. And let's move to the last part of the unit dimension, which is the dimensionless group. There are few situations where we encounter dimensionless group that are used to describe a system. A dimensionless group contains a collection of variables or parameters which are combined, giving a single dimensionless number. It's happened that sometimes after we do the calculation, we combine all the basic unit and so on. Suddenly we cancel out all the unit, and the final dimension doesn't have any unit. And one of the example is in fluid mechanics. You are going to learn fluid mechanics in the second year, if I'm not mistaken, where Renault number, you will calculate Renault number, is one of the example that doesn't have any units. And this is because after we cancel out everything. Let us I'm going to show you how it's happened. So for instance, Renault number it's equals to d v rho over mu. So d is the pipe diameter, and this is the unit is cm. V is fluid velocity, and the unit is cm over second. Rho is fluid density, and the unit is gram over centimeter cubic, while mu is viscosity, and the unit is gram per cm second. So after we arrange all of these number by considering this, it's happened that we start with d first, cm, and then we have v velocity, which is cm per second, and then we have gram per centimeter cubic, and lastly we have the viscosity, which is at the bottom, so we just going to flip it, cm second per g. Okay, so you can see here cm cancel with this 3 cm, and g is cancelled out by g, and second is cancelled by second. At the end, it's dimensionless. So this is the example of it. So you're going, don't worry if you encounter something like this. It's because it's also very normal in the engineering field. And also I want to show you, this is the conversion factor table that you will get in the Putra Blast. I will upload this. It's easy for you if you want to convert, let's say 1 kg to let's say pound. So 1 kg equals to 2.24462 pound, and length. So you can just refer to this in order for you to do the calculation. That's all for unit